In this video, I'm going to be going over some of the practice problems for this density worksheet. The first three, basically the way I have it set up is the problems get progressively more difficult. The first three are very straightforward, very basic density problems, and then they'll get harder from there. I'm going to go over one of each type, or I should say one of each difficulty level. That way you can have an example done of each difficulty, and then the remaining problems will be about that hard, or they'll be very similar problems, so you shouldn't have a problem solving them. So 1, 2, and 3. In theory, I guess I could skip these, but let's go over it. So the way we set them up, always write out your setup, D equals M over V, and then they say, what is the density of mercury that has a mass of 39 grams? So 39 grams, always include units, and a volume of 9 milliliters, or 9.0, but that's fine, so 9 milliliters. So there's my density units, and they want the density. Now here's the issue. My units of density are going to be G over ml. And the reason I know that is because the top unit has to match the mass unit, and the bottom unit has to match the volume unit, and that's because in order to get density, we divide a mass by a volume, so this unit divided by this unit has to match the density units. If they do not match, you are going to have to use King Henry to make them match, or dimensional analysis, depending on what class you're in. So you're going to have to make a match either way. There are different ways of doing it. Well, there's an easy way and there's a more advanced way, but it can be done either way. So we solve for this problem and we get the thing to be aware of with these problems is they are not hard, but what most students will do is they will lose points because they don't have the wrong, or they have the right or the wrong units or no units, and you'll lose points for that. So that's why the units tend to be actually more important than the actual problem, because the problem itself is very easy, but you don't want to lose points over a silly mistake like forgetting your units. Let's jump to number 4, because 2 and 3 are basically the same. I just rotate the variable, the x, through the different locations. So number 4 would be like the next level of difficulty. It says a piece of copper has a density of 4.4. So there's my density. That's good. It has a mass of 2.7. So there's my mass. No problem. And they want to know what is the volume. So let's take a look. And they specifically ask for milliliters. So this is like a 3-part problem. Let's just worry about what we can do now. So we always set it up like this. The mass is 2.7 grams. Density. It's very important to write the units out. The units for X are going to be in milliliters. And again, the reason I know that, they have to match. And they have to match. And so since they matched, I could plug them all in and get right to the answer. So I do my math, cross multiply, solve for X, all that stuff, and I get 0.614 milliliters. If you just called this 0.6 or 0.61, that's fine. Rounding isn't really an issue in these problems. I don't really care about rounding for most of the year unless the problem's a rounding problem like significant figures or a couple other things throughout the year. It's usually not a big deal. So there's my first step, my first answer. Then they want to know what's the volume in liters, and then they say put your answer in scientific notation. So these are like extra steps. So for this one, King Henry's daughter usually drinks chocolate milk. We are at milliliters. We want to get to liters, so that's 1, 2, 3 to the left. So if I move the decimal 3 to the left, I get that many liters. And then if I take that answer and put it into scientific notation, I'll make it a single-digit number by putting the decimal directly behind the 6, and then to get it back to its original location, I have to move it 1, 2, 3, 4 to the left. So, and I'm going to box them all in because I would get points for all of them. So on a question like this, if this were a quiz, I'd give you points for getting to here, and then extra points for getting this far, and then extra points for getting this far, depending on the problem. So that's the next level of difficulty. They're pretty straightforward. Again, if you have your units labeled, they're not terrible. 5, 6, and I believe 7 are going to be done just like that. And so I'm not going to do those. I'll leave you to do them. And then when we get to number 8 is when we get to our next level of difficulty. So when we get to problem 8, let's take a look. It says the density of olive oil is 1.4 grams per milliliter. It has a volume of 1.3 liters. What is the mass in grams? So that's our first problem. So let's set it up. So my density is 1.4 grams per milliliters, and they give me 1.3 liters. So the problem is, I know that in order to do this problem, I'm going to want my mass to be in grams, and I want my volume to be milliliters. If it's not in milliliters, I'm going to have to convert it. So right now I have liters, which is the unit, and I want to go to milliliters, which is 3 to the right, so I'm going to have to move it this way. So 1.3 liters is 1,300 milliliters. Then I'll solve for x in grams. So I cross multiply, I solve for x, and I get 1820 grams. So that's my final answer for this part. Then it says put the answer in milligrams. So I use King Henry again. I'm at grams, which is the unit. I want to go milligrams, which is 3 more to the right. I'm just going to put the decimal in. It's not necessary. I'm not worried about sig figs, but it makes it easier for scientific notation purposes. If you didn't include the decimal, that's fine as well. And then the final answer, put it in scientific notation. So remember, I'm putting the decimal directly behind the 1. I need to move it 1, 2, 3, 4, 5, 6 to the right to make it put it in the original spot. So it's going to be times 10 to the 6 milligrams. So that is the final level of difficulty. The reason this is the hardest one is because you had to be aware of the units in order to do a conversion before you started the problem, and then you ended up having to do conversions after you started the problem. So it was a before and after type of thing. 9 and 10 will look just like that, so will 11. The only trick with 11 is they're giving you the dimensions of a book in length times width times height. So if you were to multiply those together, you will get the volume in cubic centimeters or in milliliters, because cubic centimeters and milliliters are the same unit. Now, if you are in an honors class, there are other ways of doing these conversions that will allow you to make it a little bit faster or possibly move things around. That's fine if you know how to do that, as long as you get these 3 answers. I don't care if you did your conversions a slightly different way. I'm not going to get into explaining how to do it. If you know how to do it, then you're welcome to. And that concludes this video.